Hello? Ah, I think it's working now. Excellent. Right, so hello, welcome back. I've had lots of exams and stuff for the last month and a bit, and I've been a bit ill, so that's why I haven't done any streams or anything. Um, but I hope it's the summer now, so plan to be doing a lot more. So I think the first thing to do probably won't do too long today, but the main thing today is just looking over Compactor, because that's one thing that I just want to work on the streams, and what my plans are for that, because I think it would be a good thing. And then I also have some other projects that you'll hopefully see on the channel soon. I've been working on some data, not quite data visualization, but web scraping and PDF parsing to help with getting information out of PDF papers. And you can see some of the stuff on my GitHub. I'm working on that, and I'll make some videos about that soon on some of the stuff I'm working on. And I'll also be working on some other projects, such as I have a music project that I'm planning to work on to help practice. Violin is what I'm working on, but what I play mainly, but should also work for most other instruments. Piano will probably be an easy place to start, so I'll be working on that soon. So lots of things are in the works. So this is the. I think that's probably have it. Don't think that's too big. So this is the state of the code as we left it. Now, one thing that I remember is that in the tests we had. I added this long test, which was going up to, this is 1,000 characters, and that finished pretty quickly, but I think there were some of the, I remember when I started putting in longer lengths of characters, it was pretty slow, which 1,000 characters is 1,000 bytes, because each character is U8 is a byte. So that's a kilobyte, and then which is not very much, because if you want to talk into files, you could easily have megabytes or gigabytes. So I'd really want this to be able to work quickly if that was a million. But that's because I suspect now if I make this 10,000, that which would only be 10 kilobytes, which isn't very large. That's taking quite a while, and that shouldn't take that long. So it'd be good to look into doing some optimization, which I don't know a huge amount of. I haven't done very much of that in general or in Rust. So I think that would be a really useful thing to see which bits of the code are taking the most time, and where we might be able to implement optimizations. And also, at the moment, everything is set up with to work on characters. But as my idea is to turn it into effectively a command line tool to compress files, so really I think it would be better to use a U8 instead of a character, and there's no reason then why it couldn't really be anything. And down the road there might be a possibility of doing larger sections. I've heard about that, where you can have, let's say, if you're compressing text again, you would not only have letters, but you'd also have words. So, for example, the might have its own encoding because those letters appear so frequently together. But obviously, you wouldn't want every combination of 3 letters to appear. So you'd need some algorithm to find out which of those you want. So that might be an interesting thing to add. But I think the main thing that would be good is to have a command line tool. Oh, this has been running for over a minute, which is strange because I only made it 10 times longer and it took 2.7 seconds. So, well, I guess it obviously is, not sure what order it is, but it obviously isn't O of n, probably quite a bit more than that. So obviously that is going to need to be fixed if we're doing anything more, doing anything larger. But let's see. So in order to make it a command line program, that basically the idea is that you could have, at least to start off with, a file, probably a text file, but anything if it's just doing the bytes, that it then uses Huffman coding first and then other things to compress it. It spits out a file which you can then decompress. So the main things which would be required for that would be to make it faster, because this is not very good, and also to figure out how to serialize and deserialize the trees, and also what I want to do is make a trait for the left, right, and the path, because at the moment it all works on, where are we? These the Huff node types, and these all require a token. But if you are, but you don't always need that, because, just thinking, because when you're decoding, I don't think you do that. I'm trying to remember. Yes, you would need that, because that's the character that you're ultimately outputting. But basically, we need to have a way of generating this tree structure from something in the file, and from generating that. Now, there's probably a way of doing it with SERDI or something like that, but I think it would be good to try and think of a way to do that manually. And also, because the data here is binary, it's left, right, left, right. That's another possibility that I'm not sure, but I don't know the left, right, enum. This one should be pretty small, should only take a bit, or I suppose a byte, depending on how it's implemented. But I'm not exactly sure. I don't know. Enums should be as fast as if we just used a Boolean, but that might be a spot where it's slowing down. But basically, I can't figure out a good way, if you have binary data, to write that into a file, as in, or even a variable. I want to push onto this just a 1 or a 0. So I was thinking that a way to do that would be to have a vector of U8s, of bytes, and then to have a pointer into them. So then when you push, it write either a 0 or a 1, it writes to the bit that it's at, and then it increments the pointer. And then once you've got all of that, then you could write that to the file as bytes. So that's one thing. And then, of course, you'd have to do a similar thing when you got the file out, when you got the zeros and ones for the instructions. Then you would have to turn them into the left-right. You'd have to be able to go over each bit, which I'm not yet sure how to do, but I'm sure you can figure that out. So, thinking, and the other thing is that I want it to be a command line utility. So just stop this, that's taking forever. So that's a good excuse to learn clap, which is the standard. It's not part of the standard library, but it is the de facto standard argument parser for Rust. Stands for command line argument parser. And there's some pretty neat things with that. So I've basically got the idea that you could do compactor, compact, and then a file, and you could specify input, the output, what schema to do it under, and it seems like clap has a lot of really nice tools to do that, and hints and things. And then once I've got that working, then I can also look into some other algorithms. I think I mentioned this before, but I think it's the QOI, the quite okay image format, and other cosine transform and similarly based compression algorithms based on those sort of similar principles is very interesting. So I think that would be a really neat thing to work on. So for now, I could just comment this out. So my idea for, I think, in terms of file writing, I'll go over my is that we could have a struct which was something like no. Oh, I could spell it correctly. That would be helpful. A binary stack, let's say. Yeah, it is. Oh no, it's CI. And we seem a bit rusty. So we could have a binary stack which would have a pointer, and which would be usize. Now the question is, because there would be then we'd have No, I'll just call this state. Think of a better name for it. This would be a vec of U8. Then we would have, I'll call this bytes. We would then, we'd have one pointer to a bit, but we then need to go to the byte, and then, so it might be, I don't know if it would be better to have a U size and then a U8. But then the question is, how would you efficiently increment it? Because you'd want to, there is a there are overflow types. Or overflow operations, but what we'd want to know is whether or not they would, and not be an interesting question of how to do that efficiently, because if we didn't do that, I suppose we could just say that it's just loath to do branching conditionals, but I suppose what you could do is you could so if we have and then this would take mute self. So if we have that, and then we say that it would, well, we would want to, we do byte pointer bit pointer equals self dot pointer okay, that's fine. That's just unused variables. So wish I could just switch off the lens thing for warnings. That would be, no, probably don't know if you can do that. Don't even remember what it's called. Oh well, that might be something to another day. So what we'd then want to do is, if well, sort of the logic would be, if the bit pointer is 7, then we do the byte pointer +1 and the bit pointer equals 0. Otherwise we how do you do? because we want them, if I do, what does it say? Ooh. Must add, okay. Does that, it even, yes, that's much better. I guess that makes sense because you might want one to be mutable and one to be not mutable. So this is basically, I think if I will warp, assume you just put these. How do you switch that off? How do you stop those warning messages? Oh yeah. Is that better? Ooh, lovely. Oh, is that just because of that error? So this is I guess I need to can I unused assignments? That's much better. Right, so at least for now, just because yellow is annoying. So basically I can use this logic, but I don't know how much of a difference it actually makes, but it would be nicer without the so what I can do is I could do that over I can rename this later. Overflow equals bit pointer equals 7. So that will be a boolean. And then what we can do is we can do byte pointer plus equals overflow as usize, and then we can we could, I guess we could probably just do we could just add an overflow. I assume that would probably be faster. And wrapping is what. So I think there's a function. that's here we are. So what we then, I just do bit pointer dot wrapping add 1. Oh, it's not. It's not in place. Are there any to ASCII? I guess it. I guess we just do like that. And then why is it saying byte pointer is assigned to but never used, because it's used here? That's very strange. Well, I suppose we could because we want don't know how to do it. So if we try let mute bin equals binary that's that. So the pointer is going to be 0, 0. Oh, I don't know. Just make a new. Oh, no, now that error's gone away. That's bizarre. Right. New. And then that's going to return self. So this is going to be pointer 0,0 and bytes is going to be vec 0. So then I could just do here new, and then I just do print line. Invalid. Colon question mark, that's it. And then I just need to derive debug. does that? Debug. Oh, not deny, derive. Oh, that's why. Ah, right, okay, let's try again. Ah, excellent. So, and I want to change the display method so that it actually outputs that in binary instead of base 10. But I should be able to do that. So, now what I want to do is do bin.increment pointer, and then and that did nothing. Self pointer. It's very odd why it's getting these warnings. Because if I remove the mute, cannot assign twice. Is it not is it just, it's not a reference. No. That should be the actual I suppose I could do if we just get this and then we can that gets that, and then this is self.pointer.0. So now what if I make this one 7? Will it actually, will it implement, will it? So it's not bit pointer. Oh, because it's, that's because U8's a copy, isn't it? So I'd probably want to take a reference. No, I guess just replace it with this. Will that work properly now? Why is the... But why is it 8? Because wrapping add should be oh, because it's a U8, so it overflows at 255. Not I want a what I want is a U3, which I don't think. Right. Okay, so then what I can do is I'm just trying to think if there's an easier way, because at the moment I'm thinking that I can multiply by the overflow boolean and then add it, and that will have the desired behavior. Or I suppose I could, don't know if it would make any difference because the type. So what I could do is I could just do plus equals 1, and then I could do I don't think is that a yeah. So then I just do overflow as U8. Now does it work? Yes, right. So now if I make this, let's say 3. Now that works. Okay, so that is good. I'll probably want to move that out to a another module, but that can be done. So don't need that. Yeah, I suppose that's. Didn't think about that. That's a thing where the fact that their copy is actually annoying, because didn't realise that's not what I wanted. Yeah. Anyway, so I think that's working. I suppose the next thing to do is we want to do a manual implementation of debug, which I've done before, but I don't exactly remember how to do. So let's try. We want to implement I guess we would have to debug, standard format debug for binary stack, and then we'd want to format I guess that's fine. So what we right, so that's just going to be, I suppose we could just, so we have okay, right. So that's the standard formatter. So what we can then do is, because I'm sure I did, I can't remember whether it's in. Did I do one? That will just derive, not so I think you need to so we can just so we can use the right macro. And so what basically I just want to, we just want to output the bytes as binary. Okay, so I should do B. So then, well, what I could just try the examples they have is we have f dot debug struct which is going to be binary stack. No, and then you want dot field. And this is going to be pointer. Well, I'll do byte pointer. I'll just stick with them like now. Self dot pointer. Dot field. This one is going to be bytes. I'll just make this lowercase. And then the value will be self dot bytes, and then I'll do dot finish. Is that expected? These need to be references. Is that it? Okay, so that looks basically exactly the same, but now I think we'd probably want to do that differently. So there's also the implementing binary on a type. That's oh no. We want to use that. So I think we'd probably want to just use the write macro. Let's try that. So then we just want bytes, and then you want self.bytes. But then we have the U8 doesn't have it. So what we'd want to go through each byte but then if I did B, does that do anything? No. So what I probably want to do then is let mute byte string and then for byte in self.bytes we would want to byte string dot extend push push string. Okay, so then to do a reference to that requires at least. So then dot is it here, because we just need a reference to it, that's fine. And then we would do here colon B I suppose you could do a vector of strings as well, but this would be fine. Colon B, so let's see what that does. We need a argument here which would be byte. That does absolutely nothing. Oh, I suppose that. So then we'd want to do byte string like that. So that's not unexpected. So what about now? Ah, yes. But so now I should, if I do that, then we should get 3, 4, 5, 6, 7, 8. Yeah. But if we go 8 there, and if I put this back to 0, ooh, no. Ah, that's better. So now if I do 3, if I do 3, $189. Ah, yes. Excellent. So then for the debug, I will do it, make it in a similar style. Blessed warnings. So there, oh no, curly brackets, binary stack, and then do, oh, unknown escape character. Ah, I did not know that. Ah, much better. Right, so then I want pointer bytes, put some space in there, and then here put those in. So the first thing we want is the byte pointer, so this is going to be self dot pointer .0. This is going to be self dot pointer dot 1. Found. Oh, need a comma there. Right. So now, that looks pretty good. So let's change this back to 0. That back to 0. So now that should just change. So now the next thing that ooh. Happy now? Ah, excellent. We can get rid of that. And then what I can do is I can just display. for binary stack, and then yep, basically the same way, except we just, I think we basically, alright, there we are. So then if I go up to here, let me just check if this still works. Yes, and then if I do another one just like that. Ah, excellent. So then I want push bit. So I'm going to take obviously a mute reference to self. Is there any reason why it would fail? I don't think so. So then we need the bit. Now what we could just bool probably. So what we then want to do is, yeah, we want to get, no, we don't need to. So let's do let byte pointer self dot pointer dot 0 is the byte pointer first, and then yeah, then you have the bit pointer. So then we want to do self dot bytes, and then we want to index into that by the byte pointer. That's fine. And then the bit pointer, and then we want to add the bit as no. So what we'd need to do is we could get the byte. What we'd want to do is we'd want to take I don't, because if we're storing the bit pointer as a U8, instead of incrementing it each time, we can have it as a mask and just bit shift it. So then we can multiply the that mask by the so we multiply the mask multiply the mask by the boolean, and then we have what we want. So then we just OR them together, and it leaves everything else. Everything else is a 0, so it just stays the same. And then in the bit that we care about, that changes. So I'll just assume so we'll have to change the increment pointer, but what we do is we do self how do you do bitwise operators? So, and okay, OR is just pipe, okay. So we'd want to, when we increment it, we'd want to, yeah. So we would want to say this equals, I don't know, can you do that? The bit pointer, if I do that, does that? Oh wow, that's pretty neat. Let me just, does that actually work? So if we do print line, and then we do 1, 3. That should be, because we'd have 1, 1, and 1. That's OR. Ah, yes. No, because am I think so? Oh no, that's XOR. That's why. Now that should be 3. Right, okay. And if I did and 7, rather if I, that should just, ooh, turn on. That should be 7, but if I do it like this, then that should be 9. So if I let mute test equals 7, and I do test or equals, I guess, 8. So then we print test. Good. Okay. Ooh. Excellent. So now we want to make sure we have OR, not exclusive OR. So then we want to OR it with the pointer times the bit as U8. So now we need to so instead of being 7, it will be 128. So the so this is is that in the right order? Yes, that's fine. So this is the bit. This is the byte pointer. So that's fine. So the byte pointer is fine. That can stay the same. But what we want to do is we want to shift it to the left, and then, well, I suppose we can do a similar thing. Now the question is, if we have one, that's how it will start. If we have 1, and then we do that, and then so if we have 2 here, then that's 4, right? But now what happens if this is a U8 and I have 128 here? That just goes to 0. So what I could do is I could now I suppose the question is if oh, 128 U8. So then I want to test does that work? Oh, that's and then if I have 64. Ah, yes, that works. Okay. So I'll want to change this pointer so it's also B. So then I can do there we are. And then instead of multiplying it, because if that will just go to 0, it will just crush that one. So then I want to add. So if we overflow, I want to add that. It needs to. That just needs to start at 1. That's easy because it. Yeah. Excellent. And then if I have this as 128. I mean, I suppose I don't. there might be some trick that you could do, because if I just put that in a U size, or let's say in a U32, I could take the first 24 bits for the byte pointer, and then I could take the last 8 bits for the bit pointer, and then it would do all of this incrementing logic for me automatically. The question then is, what would I do when I want to read it? I'd have to shift whenever I wanted to. But I guess the thing is, I don't really need to read bits, do I? Individual bits. I'm just writing to bits. Well, which means I need to find them. So whenever I want to find a bit, I'd need to bit shift it to the right. But I suppose I can do that. But then how would you get the last 8 bits out? I'm not sure how you do that. That might be an optimization, but I'm not sure. You might just be... There's probably not very much in it either way. But right, so... And then here we want to do self.increment pointer. So let's try, instead of increment pointer, let's do push bit. Is true lowercase? Ooh. The index is 149. And that's the thing, I also then need to... that's excellent. So obviously increment pointer shouldn't push bit. I think we want public, at least for now. Obviously it doesn't matter because we're just doing it in main, but it's good to think about. Don't know if you need to make the format methods public. Anyway, to try so it probably works differently. But the increment pointer you don't want to, but if it does overflow, then we want to push another U8 onto the stack. So I suppose it might just be easier with the if statement. Pointer dot because this might make it easier, so might make it clearer. I did that. No, this is fine. So if this is on last bit, then what we want to do is we want to do self.pointer.1 equals 1, and we want to do self.pointer.0 plus equals 1, and we want to do self.bytes.push 0 as a U8. Oh, unused comparison. Oh. Okay, so else. So this is just a normal. In the normal case, we want to do self.pointer.1 bit shifted to the left. Anything else? No, I think that's it. That's just sort of in the normal case what we'd want to do. So then I'll go up here and do for I in let's do bin dot push bit, and then do I expected comma. Where's the actual error? Oh, oh, they do use percent for. Cool. There we are. And then we'd want to go like so. Oh. I want cargo run. Ah. Ooh. See, that's interesting. It's being written out of order. Oh, well, I suppose all I have to do is I have to make the bit pointer start at 128, and then in the increment pointer logic I say if we get back down to 1, then we can just set it to 128, and then we just want to shift it to the right. Ah, that seems like it works. So yeah, that's the expected behavior, and then oh, that's excellent. So that means that we can just write we just make it so we can go from our branching instruction into a boolean, or we can just write it, and then we can just write it as bits into the file. So I think that would be, there's obviously some more things to do, but I think that's the main thing, and then you can just get the bytes out, and you should just be able to write this as a file. And then of course then I think you'd want another similar structure to go the other way, that you'd load all of your you'd load the binary data from the file into something like this, and you have a pointer, and then you'd walk it across, and then you could get each one. And you could anyway. You could also probably build an iterator on top of. There's probably an iterator that gives you bytes from a file, so you could then build something on top of that, where it gave you the bits one at a time. So yeah. So I think next time I'll do a bit more work on this, and we can at some point try and do some work on the algorithm to see if we can speed it up, and then work on how we can serialize it and write it into a file. So hopefully soon you'll be able to give it a text file, small for now, hopefully more than just 1,000 characters, and then it should spit out another file, which hopefully will be smaller, which you can then run through again, and then it will spit out exactly the original text file. So that's all for today. Hopefully I'll be able to do another stream soon. I'll work on this and possibly some of the other exciting things that I've got lined up. So thank you very much.